In this episode, we will see about refrigeration and air conditioning. We will see refrigeration principle and methods. Refrigeration is the removal of heat from a space at a temperature lower than the surrounding temperature. The methods used in previous days and current are in use. We will discuss about this. Ice refrigeration, known as direct contact refrigeration system, consists of an insulated cabinet with tray at top for holding ice blocks and shelves for food and medicines are kept at the bottom compartment. The inside relative humidity is fairly high, so the food store does not dry out rapidly. You can see now also this type of package is used. Instead of ice blocks, gels are also used and filled in a cover, plastic cover. It is kept on the top, and syringes, injection syringes, medicines, and food are preserved in the ice cabinet. Next type is evaporating refrigeration. In this method, heat is absorbed when liquid evaporates. If the air surrounds water with freezing or below freezing temperature, the water tends to evaporate from its surface and cool rapidly to form ice. Artificial snow is made with this method. Refrigeration by expansion of air is the next method. When high pressure, high temperature air is expanded isentropically, that is reversibly adiabatical process. In a heat exchanger to atmospheric pressure, then the temperature falls below atmospheric temperature used in air refrigeration system. This type of refrigeration expansion of air is used. Then the throttling of gas. When the gas at high pressure is throttled, its pressure reduces and thereby temperature is also reduced due to Joule-Thomson effect. This method is used in liquefaction of gases in oxygen plant and liquid nitrogen and liquid oxygen production plant. Next method is vapor refrigeration system. This is of two types, vapor compression type and vapor absorption type. In vapor compression refrigeration system, refrigerant vapor is compressed, and the compressed vapor is when then cooled, it will become liquid, and then it is throttled to get vapor again. With reduction in temperature due to Joule-Thomson effect used in freon compression system in fridge industrial applications, this type of vapor compression refrigeration system is used. Next one is vapor absorption refrigeration system. This also used industrially only. Normally ammonia is used as a refrigerant, which is absorbed in water and is vaporized in a generator, which is condensed, and then aqua ammonia solution is there. From there aqua ammonia solution water is separated, and the ammonia is expanded through expansion valve to get reduction in temperature, and the cooling is exchanged in the evaporator, and the vapor is again absorbed in water, and the cycle is continued. This is also used in industrial application only. The next method is steam jet refrigeration cycle. Water is boiled in an evaporator at a very low pressure, and the vapor is compressed by a jet pump to high pressure and condensed in the condenser to get low temperature, which is used in refrigeration, normally used in crystallization process industries. Now we can see the properties of the refrigeration, main properties which is applied to select the refrigerant. Thermodynamic properties, boiling point. The refrigerant we have to select is at low boiling point, which is having more efficiency than the freezing point. Low freezing point is required for the refrigerant. Should be well below evaporator temperatures. Normally we require freezing point less than minus 30 degrees centigrade. This will be used in a cryogenic application also. So there are methods we have seen, and the properties also, main properties, physical properties are boiling and freezing point is required for selection of refrigerants. Now we can see the refrigerant nomenclature. What are the refrigerant used? How it is named? We can see now. The refrigerants are mainly methane and ethane based. The two digits number derived from methane base and three digits from ethane base. The last digit in the two digit refrigerant gives the number of fluorine atoms present, and the digit penultimate equals one more than the number of hydrogen atom present, and not accounted in it is chlorine atoms. Now we can calculate how the refrigerants are named and the chemical name. Chemical formula is CmHnClPfQ, and it is N plus P plus Q is equal to M plus 2. This formula is applied to find out the refrigerant with the name and chemical formula. R M minus 1 N plus 1 Q. For example, R12, which is used in still used in India in fridges, R12 or R22 and R13 or 11 are used previously also. R12 is, we can see how it is calculated. It is a 2-digit, so it is methane base. Last digit is 2, so last digit is fluorine, and the number of hydrogen atom, the penultimate is 1, N plus 1. So 1 minus 1 is equal to 0, which we required because N is equal to 1 minus 1. So hydrogen atom is 0. Balance is the chlorine atom. Methane is having CH4. So chlorine atom is required is 4 minus 2 is equal to 2. So R12 is CCl2F2. That's known as dichloro-difluoromethane. Then we can see similarly we can see R11 as CCl3F, trichloro-monofluoromethane. R13 is CClF3, monochloro-trifluoromethane. R21 is CHCl2F, dichloro-monofluoromethane. R22, which is normally used in industrial application, also in fridge, CHClF2, monochloro-difluoromethane. Then R30 is also used in some industries, CH2Cl2, methylene chloride, and R40 C3Cl, methyl chloride. All these are banned in US and Europe countries. In India, still some refrigerants are used, which will be banned soon. Then R32 CH2F2, hydrofluorocarbon. This is now in use. You can see refrigerant nomenclature and desirable properties also. R113 is a 3-digit ethane base. As mentioned in the PS formula, M minus 1 is equal to 1. So M is equal to 1 plus 1 is equal to 2. N plus 1 is equal to 1. So N is 1 minus 1 is equal to 0. Q last digit is 3, which is fluorine. So N plus P plus Q is equal to M plus 2. This is a common formula. Now we can calculate the chlorine atom percent. P is equal to 2M plus 2 minus N minus Q. That is 2 into 2. M is equal to 2. So 2 into 2 plus 2 minus N minus Q. So it will come to 3. Hence chemical formula is C2F3Cl3, trichloro-trifluoroethane. This is the chemical name for R113. Similarly, we can calculate for R114 C2F4Cl2, tetrafluoro-dichloroethane. R115 is C2F5Cl, chloropentafluoroethane. And the desirable properties and how it is refrigerants are classified, we can see HFC, hydrofluorocarbon, and only fluorine and carbon are present. It is called HFC. 152A is a common refrigerant use. Is a specific isomer when it is A is provided in this. It is CH3CHF2 difluoroethane, and it is used in some industries, and R134 is still used in industries and domestic application also. It is also HFC, hydrofluorocarbon, no chlorine present. The A is for specific isomer. CH2FCF3, tetrafluoroethane, so no chlorine is present. This is still in use, but it may be banned soon. Chlorofluorocarbons is another type, CFC. It is already banned in US and Europe countries. Hydrochlorofluorocarbons, HCFC, this is also banned. hydrofluorocarbons, that is we see earlier, still it is in use in India, and some are used in Europe also, will be banned soon. Now we can see the main residual properties. Ozone depletion potential (ODP). Now it should be zero. All the refrigerants now used in fridge and air conditioning and industrial applications should have ODP to avoid ozone depletion. Then the global warming potential (GWP) also look into account, should be also less or zero. Then the total equivalent warming index TEWI also should be very low. Refrigerants having non-zero ODP have either already been phased out, that is already banned in US and Europe countries. These are R11, R12 and R20. Still we are using in our country, some of the places where it is used. Since ODP is mainly depend on the presence of chlorine or bromine in the molecules. So chlorine and bromine will deplete the ozone layer. So it is banned universally in all other countries except some countries only it is using. Refrigerant should also have a low GWP value as possible to minimize global warming. Refrigerants with zero ODP but a high value of GWP like R134A still we are using in fridge and in air conditioning unit and industrial application also. It will be banned soon. Now in India and Gulf countries and some places still R134A is used, but US and Europe are banned almost. Already it is banned. Now we can see the refrigerant comparison and issues. This is a type hydrocarbon. HC290 is a propane based. CH4, that is methane. It cannot be used in commercial AG or domestic purpose. It is flammable, but it can be used in industry. Propane is used in cryogenic process in industrial application, in LNG plant and LPG plant production unit. Chlorofluorocarbon CFC. Example is R11, R12, R113, 114 and 115. It is having high GWP and contain ozone depleting because of chlorine and fluorine. More sample and was phased out. So already it is banned in US and Europe countries. Some of them are used in India. HEFC hydrochlorofluorocarbons. These R22 and R23. Though is having very good effect, but it will deplete ozone layer. ODP is also there and GWP is also high. So it contains chlorine. So it is harmful and it is based out in US and Europe countries. But still in some places R122 and 123, R22 and 123 is used. HFC is hydrofluorocarbons without chlorine and bromine. 134A, 404A, 407C, 410A, these are all mixtures of 2-3 refrigerant. So it is having zero ODP. Ozone depletion parameter is zero, but GW is high. So still it is used in air condition, refrigeration and industrial application. Maybe it will be banned soon. Now we can see refrigerant in current use and future use. As we seen earlier, R134A ODP is 0 plus GWP is 1410. It will be banned in future, but already it is banned in US and Europe countries. In the future, now and also in future from 2025, these are all the refrigerants will be used in domestic application and industrial application universally. Domestic usage is R600A is a common name for a high purity isobutane C4H10, that is R600A. It is non-toxic. It doesn't deplete the ozone and is a negligible contributor to the greenhouse gases. That is GWP is in negative is minus 20. So this is most preferred in use now. It's still in use in US and Europe countries. So and it will be continued. This is the future refrigerant for domestic application and industrial application also. R600A are known to be highly inflammable. To prevent that, it is hermetically sealed within the refrigerator as part of the product safety standards. So it is sealed hermetically, so it cannot leak, and it is not flammable if it is hermetically sealed. So it is used in domestic application. Room AC CH2F2 hydrofluorocarbon, that is normally HFC 32, and it is ODP is 0 but GWP is 675. And next one is R290, this is propane base, is also named as HFC 290. It GW also very less, so it is used in room AC in US and Europe countries. These are still in use and will be in used in future also. For industrial application, R600A, R290 ammonia and carbonate. Specifically for industrial application is used in chiller units, or 600A, 290 ammonia and carbon dioxide. For industrial applications, small chillers and medium type chillers, R32, that is hydrofluorocarbon, which is used because GWP is 675 only, and R290 is very less, that is propane. It is used in small chillers. For large chillers, new chemical refrigerant R1234ZE. It is C3H2F4. Chemical name is 1333 tetrafluoropropane. It is used in large chillers in industrial application in US and Europe countries. Its GWP is less than 1 and ODP also 0. So for industrial application and domestic application, these are all the refrigerants in future. These are future refrigerants universally uh, universally to be used from 2025 onwards. Hope you might have understand the refrigerant's name and chemical formula, how it is calculated, and what are all the refrigerants used now in India and in abroad countries which are all banned. In the next episode, we'll see about the domestic fridge operation and the selection of fridge, how the fridge is operated, and what type of fridge we have to select. We can see, and industrial application of refrigeration in chilled water and chilled brine units, and LNG cryogenic process also we can see in the coming episode. Do not forget to subscribe and share. Please put your like and comment in the comment box. See you in the next episode. Thank you very much.